All right, so we had to come up with, go ahead and click them close for just a second. I know you might think you have all this, but I want to make a couple of points that are really important. You're doing the assignment, this will help. So we know that we've got, the 3 questions are being asked, right? So there must be 3 variables here. We're trying to fill in the values of the 3 variables, and so that we define those as being X is the number of pounds of Empire apples, Y is pounds of Red Delicious, Z is pounds of Golden Delicious, right? So if we have 3 variables or 3 unknowns, how many equations do we have to have at minimum to solve that system? We've got to have at least 3, right? So we got to come up with 3. So then we have to take this, this word problem, this application, and we've got to extract from that information. We've got to be able to extract 3 independent equations, or we can't do it, right? So we found one was, and this is really typical. You've seen, most of the word problems you've dealt with where you're solving linear systems, going back to Algebra 1. There would have been something like this. There would have been one like total cost equation, right, where you've got the cost per, per type, like per pound of each type of apple, right? So that's a coefficient is what that ends up being, right? So we're going to multiply. I know if I want to come up with the total cost of all the Empire apples, and they cost $1.40 per pound, and we have X pounds, doesn't it make sense that 1.4X is going to be the cost of the, what were those, the Empire apples? Right? And if the cost per pound for Red Delicious is 165, then we get another term that's 1.65 Y, right? And then the cost for Golden Delicious is 175, so we get 1.75 Z. And so if that's the cost of each individual, the total cost of each type of apple, they must be equal to the total cost of everything, which is given to us as 2420, right? So you're probably used to seeing that kind of an equation pop out of a linear system problem, right? So there's the first one. What are the other 2, though? Well, they can be kind of sneaky. They can be disguised. If we know that we have 15 pounds in total of all apples, and if these are the variables represent the number of pounds of each individual type, then X plus Y plus Z equals 15. That's real common also, right? Where there's going to be a total count of all the variables. Now, what about the last one? The last one's maybe a little bit trickier, and this is where we left off. We want twice as many Red Delicious apples as Empire apples and Golden apples combined. Okay, so the Red Delicious is Y, right? So if this is describing the amount of Red Delicious apples that we want, correct? So we can set this up as a Y equals equation then, right? Okay, so how am I going to say that then?
Y equals 2 times X plus E.
There you go. So we want twice as many as the other 2 combined, right? So the number of pounds of the others would be X plus Z, and we got to multiply that whole quantity by 2, because we want twice as many as both of those combined. Everybody agree? Okay, so then there's our linear system. To put this in a form where we can do this on using matrices, you tell me, is the first equation in a good form? Yeah, it is. That's in standard form, isn't it? Right? Second equation. Yes. Third equation. No. Third equation, we got to flip around a little bit, don't we? So we'd have to do a little simplifying on this third one. What would we do? Distribute the 2 maybe, right? So we're going to get Y equals 2X plus 2Z. And then how about if we just subtract the Y to this side, leaving us with the other side of the equation being what? 0. Okay, so would you agree then we end up with 2X minus Y plus 2Z equals 0? Okay, and so then now we can put this in, right? Put this into our calculator, and this is a linear system problem. So let's do this one. Just quick reminder how we do this on the calculator. Good. Okay, so you guys walk me through this then. No logarithms. Logarithm we'll talk about later. Oops. Okay, so there's what we're trying to represent. Here's our calculator. Oh man, come on. Okay, so where do I go on the calculator? Matrix. So I go second, matrix. I can pull up, I've already got look, there's a template already set up. My matrix D is already a 3x4. Yours might not be, so you might need to build one. Here, maybe I'll build one too, just so we can start from scratch.
So it's a 3 because like the X, Y, and Z.
Say it again. Right. So it'd be 3 rows and 4 columns. So the 3 rows would be the 3 equations. The 4 columns would be each of the coefficients and then the constants on the other side of the equal sign, right? Okay, so I'm just gonna choose. We gotta go to edit, right? Edit menu, and I'm gonna choose 5. So I'll make matrix E. It needs to be a 3x4. So there's the right template. And what are gonna be the numbers I'm gonna type in?
1.4.
Okay, so 1.4, enter. 1.65, enter. 1.75, enter. 24.2, enter. So there's my first equation, and then 1, 1, 1, right? 15. And then 2, -1, 2, and then 0. Now, what if I had an equation that was missing an x or a y or something? What would I do? Put in a 0 coefficient, right?
Location of that -1 matters.
Say it again.
Location of the -1 matters.
It does, because it's coefficient of y. Okay, so there's my matrix. Now what? Now what?
Back out.
Okay, so I got to quit. Go back to matrix.
Go to 5.
No. Math. Okay, I'm going to go up to RREF, reduced row echelon form. Now,
Back to
matrix
matrix.
5. And then technically I should probably, T count, there you go. So I should probably close the parentheses, but it doesn't really matter because there's nothing else in there, so I'm going to be lazy and not do it. If I hit enter, what's that telling me?
3 of the 1 apples, 10 of the other apples.
There you go. Okay, so take a picture. Oh, I wonder how. Ooh, I'm foiled. I can't do that. I think I have to do. My goodness. Capture screen. There we go. Oh, now never mind. I was just being dumb. I can do it. Okay, so my answers then are from here. Right, we know that. Oops. This one's telling me that x equals 3, this one's telling me that y equals 10, this one's telling me that z equals 2, right? So my answers are just 3, 10, and 2, right? Okay, good. Go to work. You got it.